Yeah, hello. Yeah. So, good afternoon, everyone, and welcome back to the class. So, in last class, we discussed about pandas operations. So, we talked about different operations that you can do using pandas, such as getting unique values in a column of a data frame or in a series, getting the number of unique values, getting the count for each of the value. We also talked about indexing and selecting data in a data frame. We talked about applying functions such as sum or other custom functions using the apply keyword to pandas series and data frames. Uh, yeah, we also talked about removing columns, getting column and index names, sorting and ordering of a data frame, finding null values, then dropping null values, filling null values with something. Uh, yeah. We also talked about changing the shape of a table data frame using pivot underscore table function. Uh, we also talked about the group by method, which allows us to group the data frame by certain columns and then call aggregate functions on the rows to get some aggregate values such as uh, sum or mean or maximum, minimum, standard deviation, and all basic statistics using describe. We also talked about transpose, how it transposes a data frame, like changes the columns into rows and rows into columns. Mm. We also talked about three major ways of combining data frames. So using merge, using concatenation, using merging merge, using uh, join also. We also talked about the right outer join, inner join, and left and right joins, joins and concatenations and all. At the end of the lecture, we had some exercises. So this is an answer for the exercises. So we'll go through it. So first we need to import pandas and numpy. We can do that by panda, import pandas as PD and import numpy as NP. So basically we do this so that the functions that we call later don't use a lot of letters. We just can write PD dot something NP dot something. It's slightly easier. The first question here was create a pandas series from each of the items below. Okay, list, a numpy array, and a dictionary. So we are given a list, we are given a numpy array, and we are given a dictionary. So what we'll do is we'll first run this. Mm, Yeah, we'll first run this. Then we can create a series by just passing a list to pd.series. We can also do the same by passing a numpy array or a dictionary to pd.series. So this is quite straightforward. We do this and we get three series that are defined in this list, array, and dictionary here. Okay. The next question was combine the following series to form a data frame. So we have two series here, series 1 and series 2. We can see series 1 is basically all the alphabets, and series 2 is basically numbers starting from 0 to 25. So to combine, we have these two series object. We can just call data frame on them and reset the index. So we'll get a data frame where both of these are the different columns of the data frame. Okay, so pd.data frame in the bracket we have provide both of the series that we have, series 1 and series 2. Then we write reset index so that the index is reset. Right. Okay. Get all the items of series 1 not present in series 2. So we have two series here, series 1 and series 2. Series 1 basically has 1, 2, 3, 4, 5, and series 2 basically has 4, 5, 6, 7, 8. So we want all the items that are in series 1 but not present in series 2. Okay. So basically we want 1, 2, 3. Okay. So what we are doing here, we are indexing series 1. So in the square brackets, we are writing an index. So the index is not in series 1 dot is in not series 1 dot is in series 2. So basically what we are doing here is series 1 dot is in series 2. This code basically what it does is it selects items that are common to both. So since 4 and 5 are the items that are common in both, it returns true for those indices and false for the others. When we put this tilde in front of it, what it does basically, it just reverses the whole thing. So now we have all the items in series 1, which are not there in series 2. So we get this Boolean metric mask, and we just index the mask on the series. And so we have 1, 2, 3. So just the elements that return true. Okay. The next question is get all items of series 1 and series 2 not common to both. So basically we need to find items that are only present in either one of the series. Again, we have the same series 1, 2, 3, 4, 5 and 4, 5, 6, 7, 8. So basically what we want here is 1, 2, 3 and 6, 7, 8. Since 4, 5 are common to both. So what we can do is we can get the union of both the series as defined in sets. So there's a function called np.union1d. So it basically calculates the union of two objects, one-dimensional objects. Then we provided the object series 1 and series 2. These can be numpy arrays or these can be pandas series or data frames also. Okay, so we get the union. Then the next step, we get the intersection using np.intersect 1d. Okay, so basically we have the series and the intersection, union and the intersection. If we run these codes separately and we type series, so this is basically the union which contains all the elements, and intersection will basically contain the elements which are only there in both of them. So now again using similar logic as before, we check whatever is there in series U, which is the union of both the series. Is it there in intersection also? Then we take the negative of that. So if it is there in both union and intersection, we don't want it. If it's only there in union, we want it. Okay. Then we index it on the union series. We get 1, 2, 3, 6, 7, 8. 4, 5 are basically not there because 4, 5 are there present in both of them. Okay. Mm, so we are provided a series below state and state.normal. So this basically creates a state variable that we can call later to get like uh, randomly picked values from normal distribution with certain parameters, mean, standard deviation and all. So we do that, we get some certain random variables. Then we just write series.describe, which will give us all the things that we are asked for. It will give us the minimum, it will give us the maximum, it will give us the 25th percentile, median, the 75th percentile, mean, and the standard deviation. Okay. The next question is stack series 1 and series 2 given below vertically and horizontally. So we are given two series. Let's just look at what the series are. So series 1 is basically numbers 0 to 4. Series 2 is basically ABCD. What we can do is pd.concat, which basically concatenates two series, and we give axis equal to 0. So what this does is it basically vertically concatenates everything. We have 0, 1, 2, 3, 4, and then A, B, C, D, E. Now, if we were to give axis equal to 1 as our argument to this pd.concat function, it will give us basically, it will stack them horizontally, column wise. So now we have both of them in two separate columns. Okay. The next question was extract all items from series at position given in list position. Okay. So we are given a list here, position. We are given a series here, which basically all the alphabets again. We use the function called take. So series dot take, and in bracket we give it the indices that we want. What it will do is it will basically get the uh, alphabets present at those indices. So at 0 index it's A, at 4 index it's E. So it also gives us the indices as row labels. We don't need to worry about that, like matching it up. Okay. The next question is compute the mean squared error on the following series consisting of true values and predicted values. So basically we have a series of true values and a series of predicted values. Hmm. So this is how the true values look. It's just basically 0 to 9, and predicted values is basically 0 to 9, but there's some error associated with it because we are adding something random to this, basically. Okay. So what we need to do here, we need to calculate the mean squared error. So mean squared error is basically we take the difference, we square it, add all of it, and then take the mean of it. Okay. So here basically we are subtracting the predicted values from the true values. Then we are squaring it up, and then we take the mean. So mean squared error. Right. It's quite straightforward. We just get one value for the whole series. Okay. The next question is convert the first character of each element in the following series to uppercase. So we talked about map and apply and all for NumPy and for pandas. So basically we are given the series here, how to learn pandas. If we just print it out, it's all in small letters. So what we do is series.map, which basically maps a function to each of the elements in the series. We are providing it a lambda function that we talked about earlier. So lambda x is equal to x dot title. So dot title is basically a string function. So if I have something like erase or something, and I write dot title, what it will do basically is it will convert the first letter to title. So it's called title keys. Now if I were to do the same thing, erase dot upper, it will basically convert everything to uppercase. And if I do erase dot lower, will basically convert everything to lowercase. So we are using the title function here since we just want the title case or the first letter to be capitalized. We use map and then we use the lambda function and we get how to learn pandas. So basically the first letter in each of these word has been converted to capital now. Okay. The next question is compute the mean of weights of each fruit. We are giving a we are given a series called fruits, and we are given a series called weights. So basically, fruits is a series which is either banana, apple, carrot, or any of those, and we are given the weights for each of the corresponding values. So banana, the weight is 1. In the second case, apple, the weight is 2, and so on. Whatever arbitrary units. So what we can do here is we can group by the weight series that we have, group by using fruit. Notice that even if they are both independent series, we can group by one with the other because they have indexes, similar indexes. Okay. And then we call the aggregate function mean. If we run this, we just get apple, what is the mean, banana, what is the mean, and carrot, what is the mean. So we can see for banana, it's 0, 3, and 6. 0 is 1, 3 is 4, 6 is 7. So the mean of it will be 7 plus 4 plus 1. which is 12 by 3, which should be 4 bananas. Similarly, for the rest of it also, it calculates. Okay. Join data frames DF1 and DF2 that are provided here by fruit pasam and weight kilo. Okay. So basically, fruit and pasam we want to uh, set as the same columns in both the data frames, and weight and kilo we want to set as the same column in both the data frames. Okay. So let's take a look at the data frame. So the first one looks like this. It has fruits, it has weight and price. Second one also fruit, weight and price. So what we do here is we merge these two data frames. So merge df1, df2. How is inner? Since we only want the common rows, so we'll do a inner merge. Left on will basically tell you on the left hand side which two, how many, whichever columns you want to merge. So fruit and weight is are the columns that we want to merge, and right on is basically on the right data set. So df2 here, which columns we want to match with it. So pasam and kilo, and suffixes we basically write what suffix they should provide. So for other columns, for example, the price column that is there in both of them, it basically what it does is price left, it gives you a left ka value, price right, it gives you a right ka value. But notice that these things are basically the same now. Apple, orange, orange, okay. And again, these values are repeated because it just occurs once, but here it occurs multiple times. Right. Okay. So that was it for uh, module 4, which was pandas. Now in module 5, we'll talk about uh, something called Matplotlib. So Matplotlib is one of the most important libraries that we use to visualize our data. Data visualization in data science is one of the major steps because it helps you get a feel for what your data looks like and if there are any uh, inherent relations that you can visually figure out. So let's say you are plotting two variables x and y. By just looking at the graph of the plot of x and y, you can tell certain things about, like, let's say if they are uh, increasing at the same, like if x is increasing, y is also increasing, or if x is decreasing, y is also decreasing. Then, like, you know that both the variables are somehow correlated, or maybe one of them depends on the other. So you'll do tests to figure out what is the case. You'll do more statistical tests, or you run models, or you fit some curve through it. So basically, this plotting and visualization part helps us get a feel for the data and helps us to, like, uh, basically determine what next we should do to the data. Okay. So Matplotlib is the go-to library in Python for data visualization. It can help us create different types of visualizations of our data, such as line plots, scatter plots, histograms, pie charts, box plots, etc. It also supports plotting in 3D. Okay. Mhm. Sorry. So before we get started, in case you have not installed Matplotlib till now, you can do so by running pip install Matplotlib in your virtual environment or Python environment. You can also run pip install matplotlib here in the Jupyter notebook. So you basically write uh, what is this exclamation mark pip install matplotlib. If I run this, since I have already installed matplotlib, it should tell me requirement already satisfied. But in case you have not installed, it will install it for you. Okay. So Matplotlib, this library was basically inspired from MATLAB's plotting library. So Matplotlib basically stands for MATLAB plotting library for Python or something. So if you're familiar with MATLAB, then Matplotlib will feel natural to you. It is an excellent library to get started with plotting and everything, but initially it is slightly difficult to like get hold of a lot of things. But we'll do step by step. We'll go very slowly in today's class and we'll step by step analyze what all is happening. Okay. Uh, yeah. Before this lecture, it might be great if you just explore this website, matplotlib.org, which is basically the website for Matplotlib, where they tell you about how to install, and there's some tutorials and some documentation and everything. Okay, so we installed Matplotlib. So for importing, what we do is we import matplotlib.pyplot, which is a submodule in Matplotlib, as PLT. So this PLT, since we don't want to write this big of a name, we import it as PLT and we can just write PLT everywhere. Okay. So this basically imports the library. If you are working on Jupyter Notebook, sometimes your plots and all might not be visible and the graphics might not be that great. So we basically run percentage matplotlib inline. So this is a magic function in Jupyter which helps set it up for plotting with matplotlib. So your plot should look normally as they would look. Okay. You can also try out without running this, but I would recommend running this. Okay. If you are using any other editor, you don't need to bother with this thing. Okay. Okay. So we'll first look at a very basic example. Okay. One second. Yeah. So basically here we are creating two variables, x and y. So first we'll import numpy, then x will be linearly spaced numbers between 0 and 5, and we want 11 such numbers. Then we see what we get in x. Basically, we have 11 numbers from 0 to 5, which are evenly spaced. Then y is, we have defined as y is basically x raised to the power 2. So it's the square of all these numbers. Now, if we show this, it's basically 0 square 0, 0, 0.5 square 0.25, 1 square 1, 1.5 square 2.25, and so on till 25. Okay. So once I give you this sheet, this Jupyter notebook today, I asked you to just go through it and look at all the functions here that we have. So uh, VS Code basically gives you a short uh, help kind of thing to show you what all uh, parameters or arguments this function takes. But I would urge you to go back and look at Matplotlib for all the different arguments that these functions can take. Okay, because most of these functions take a lot of arguments and it's not really easy to easy or like basically needed to show everything here, but there might be specific cases where you might need something that we have not discussed here. So in that case, I would suggest you to just mm, go to matplotlib.org and look up all the different functions that we are using today, such as plot, x label, y label, and all. Okay, so let's go line by line what is happening here. Okay, we'll first use the first line, which is basically plt.plot. Plt is matplotlib.pyplot that we had imported here. Okay. It's not matplotlib, it's matplotlib.pyplot, which is a submodule of matplotlib. Okay. So we give it the x axis what we want to plot and the y axis what we want to plot. You need to make sure that x and y have equal dimension and are 1D, one dimensional, and have the same number of items. Otherwise, it will throw an error. And R here is basically the color, red. So if we now run this code, we'll see we have X and Y. It looks like a square curve and the color is red. Okay. Now what we do is we add these two lines. So basically plt.x label, plt.y label. So once you have created a plot, you can set the label of the x-axis and the label of the y-axis using these functions. So in the argument, you just pass a string that you want to show. Okay. And you run this and we see that the x-axis title that we put here has come down on the x-axis here. And the y-axis title that we put here has come here, y-axis title. Okay. Then we have another function called title, which basically gives your whole uh, plot a title. So now the title comes up here for the whole plot. Okay, and then so this plt.show is something we don't need to bother with here, but I have just kept it just in case you download a Python file or something. In that case, to show your plot, since the Python file you'll be running inside a terminal, to show the plot, you have to call this function plt.show, which will open the plot in another window, basically. So if I was to show you how it looks like, so this is basically a terminal. Okay. I don't need to create a Python file. I can just write Python. And the prompt here is basically giving me like, I can basically write Python code directly into the interpreter and it will interpret it line by line. Okay. So what I'll do here is I'll import numpy as np. Okay. And I'll write x equal to np dot linspace 0 to 5, 11. Okay. And I'll write y is equal to np dot linspace. Sorry, y is equal to x raised to the power 2. So now we have x and y arrays. Now we also want to import matplotlib dot pyplot as plt. Okay. Now we write plt dot plot x, y, and I give it here b. So the plot should have a blue color. So now it basically created a plot object. When you write plt.plot in the command line, it does not show you anything. When you write plt.show, it basically shows you a plot. Just a second. Share my screen again. Okay. Now you see a plot that is in a separate window. If I were to just write it again, plt.show, okay, I have to do the whole thing again. plt.plot, plt.show, it shows me a plot in a separate window. So that is why we need the plt.show, but in general, we don't need it. We'll mostly be, sorry, we'll mostly be okay without using it in the Jupyter notebook, since we have used the command here, matplotlib inline. So that basically runs a couple of functions in the background, which lets you plot in the Jupyter notebook without calling plt.show. And it does not open the plot in another window. Okay. So now let's just change the titles here and just write it as X, write it as Y, And in the plot, I'll write y versus x. Right. So the x-axis label here is x, y-axis label here is y, and the title for the whole plot is y versus x. And we are plotting x and y, and the color here is R. We can also write red here, which will give me the same. Sorry, it's red, not that. Huh. Which will again give me the same plot. I can write many of the common colors are available on Matplotlib. Red, blue, yellow, black, and all of that. And a lot of other colors also are available by name. So we'll mostly be using those. I think there's a really well put uh, page on colors. So if you can see this here in Matplotlib website, we can basically see that we have, so these colors you can just blue, green, red, cyan, magenta and all, you can just use a single letter to denote. Then you can use this tab colon blue, tab colon orange to get these colors, which are also present in another program called Tableau. We can get all these colors by writing just their name. So there are a lot of colors here. You might want to check it out to see if any of them you want in your plots and all. Okay. Then one of the most widely done things in Matplotlib is to make multiple plots in one plot. Okay. So basically what we do here is we basically use something called plt.subplot. So plt.subplot takes three arguments. Okay, you can write a comma in between them, or you can just give it the arguments 1 to 1. Okay, the first one is basically the number of rows you want. Second one is number of columns you want. And the third one is what is the plot number of the current thing you are going to plot. Okay, so subplot 1 to 1. So it should have one row and two columns. And the plot number we are trying to plot now is the first plot. Note that Matplotlib is one index, unlike Python, which is zero index. Or is it zero? I'll just say. Yeah. So then once you write this, basically Matplotlib, what it does is it creates a subplot. And since we just wrote 1 to 1, it just created one. Now if I were to copy this and write this, basically create two, because now I'm creating two subplots from the same thing. Right. Let's see what happens if I put a 3 here. It says error because we are defining that it has one rows and two columns. So maximum it will have two plots. That is what it is plotting here. The third one it can't plot basically. And so basically we get this thing. So here what we are doing, we are creating the first subplot, then we are plotting something there. Okay. Then we are creating the second subplot and we are plotting something else here. Now if we run this code, we basically, so this is x versus y, this is y versus x, and r dash dash. So r is for the color. The color here is red. Dash dash is basically the line type. Okay. So Matplotlib has a lot of different line styles that you can use. Okay. So it has these solid, dotted, dashed, and everything. Okay. Uh, how you can get them is by writing these names. Okay, loosely dotted, dotted, densely dotted, and so on. You can also, for some of these styles, you can do this. So double dash is basically a dashed line. and here G is basically the color green here. Star dash basically plots a line which has a number of stars in between. So it's a line and there are a lot of stars on the line. Okay, so this is what we got here. So this is basically the basics of plotting using Matplotlib. You can mostly we use the plt.plot function to plot when we are plotting scatter plots or something. Line plots. And then we can also use this plt.subplot to create multiple plots in a bigger plot. Okay. Hello. Yeah. Uh, so now that we have seen the basics, uh, we'll have a more formal introduction to object-oriented programming in Matplotlib. So basically, what we'll do is we'll make objects of figure type. So figure is basically a type in Matplotlib. We'll make objects of that type, and then we'll call the methods from that figure object. Methods or attributes that are defined in Matplotlib for a figure object. Okay. So this makes our life easier when we are working with multiple plots. Okay. So here what we are doing in the first line is we are doing figure is equal to plt.figure. This basically creates a figure object. Okay. Which is basically an empty canvas. To write this, it created a figure with these sizes. If I write plt.show, it doesn't show me anything because it's just an empty canvas. Okay. Then what we do here, we add axes to the figure. Axes are basically x-axis, y-axis, and so on. So here we are adding axes to the figure. So now we have the axis. So this is for the left and the bottom value. What is the leftmost and the bottommost value of the plot? Where does it start? So we are starting it from 0.1 from the figure. Okay. And then 0.8, 0.8 is basically the width and the height of the plot. So left, bottom, 0.8 is the width, 0.8 is the height. If you were to write it as 0 here, 5 here. Okay, since it's not, layout basically comes up after you plot a lot of things. So it basically now added axis. Okay. Axis equal to figure dot add axis. And we add the axis in this way. We give it the left, bottom, width, and height. Then we plot on that set of axes. So we got the variable axis here from the figure element. Using this method, figure dot add axis basically adds an axis to the figure and then returns the axis to you. So you can store it in a variable. And then we write axis dot plot x, y, and b is basically the color blue. Axis dot set underscore x label. So note that when we were directly using the plot method here, plt.plot, what we were doing was plt.x label, plt.y label. But when we are using axis object, the figure object and axis in this way, what we are basically doing axis dot set underscore x label. So this will set the x label, the label of the x-axis. Set underscore y label will set the label of the y-axis. Set underscore title will set the title. If we run this, we get the same plot. Set X label, set Y label, set title, because that is what we provided here as strings. Okay. and the color is blue since we provided B here. If you were to change it to red, it will be red. Okay, so it adds a bit of extra steps, but the advantage is that now we can tell Matplotlib where to add a certain axis in a plot. And we can easily add more than one axis into a plot. So I'll do it here. Figure is equal to plt dot figure. So this creates a figure object. Then let's say we have two axes. Axis one will be figure dot add axis. And we give it the values 0 0.1, 0 0.1, 0 0.8, 0 0.8. Then axis 2, we add another axis to the figure and we give it the value 0 0.2, 0 0.5, 0 0.4, 0 0.3. So it's basically like start 0 0.2 towards the left, start 0 0.5 from the bottom, the width should be 0 0.4 and the height should be 0 0.3. So if I just do this, we see that we have two axes now. So the first one starts at 0 0.1, bottom also 0 0.1. Left the margin is 0 0.1, bottom the margin is 0 0.1. It height and width it has 0 0.8, 0 0.8. So it's a square plot. The second one, however, on the left starts from 0 0.2. On the bottom, it starts from 0 0.5. So from the bottom, it's halfway up. Okay. This is basically fraction of the figure size. 0 0.4 is basically the width and 0 0.3 is the height. Since both of them are different, we have a rectangular plot here. Okay. So now what we are doing here, we are basically instantiating a figure object. We are adding two axes, axis 1 and axis 2. In axis 1, we are plotting x, y, blue color. We are setting the x label, y label. We are setting the title. In axis 2, we are plotting y, x, and in red color. We are setting the x label, setting the y label, setting the title. Okay. Now if we were to run this, you'll see basically in axis 1, we plotted x, y in blue color. We have that in axis 1. The x label is x label axis 2. So it should be axis 1. Y label axis 1. We run it again. X label axis 1, Y label axis 1. Then we have axis 1 title, which is the title of axis 1. In the inset, we have another figure, another axis where we have plotted y versus x. Y is on the x-axis, x is on the y-axis. So we should basically write y label here and x label here. So this is y label for axis 2, x label for axis 2, and this is the title for axis 2, which comes up right above axis 2. Okay. So using a figure object basically gives us a lot of freedom in how we want to place axes in a figure, what we want to do with those axes, and all of those things. Okay. So the plt.subplot thing that we used before here. So plt, the subplot function, helps us make subplots and then use them directly. So here, basically, we are creating a subplot which has one row and two columns. We are taking the first figure here and we are plotting inside it. Then we are changing the figure to the second figure and we are plotting something else inside it. Okay. Matplotlib also has another function called figure.subplots, plt.subplots, which basically gives you a figure object and an axis object. Okay. So plt.subplots gives you a figure object and an axis object. In the axis object, as before, you can plot, you can set x label, set y label, and set the title. If you were to now run this, you'll see that the title is title, the x is x, the y is y. It's plotted in red color. We are plotting using the axis, and plt.subplots function that we have here basically returns a figure object and an axis to us. Okay. So when we are creating subplots, what we can do is basically we can tell it how many rows and how many columns you want in the subplots. So in the axis object before, so here when we run it, we see if we print out the axis object, it's basically an axis object. And since we have provided the titles here for title, the X label, Y label, it has all those things. It is a single axis object. Okay. Now, if we were to do this, plt.subplots, number of rows is 1, number of columns is 2. Basically, 1 row and 2 columns. We see that the figure object looks like this. And if we were to check how the axis object looks, it's basically an array of axes put together. So this is for the first axis, this is for the second axis. We can iterate through the array for plotting. Okay, so basically what we are doing here is the axis object here is an array of different axes. So we are iterating over it using a for loop for axis in axis, axis dot plot, x, y, blue, set label, set y label, and title. Then this for loop goes to the second object. It does the plot, it sets x label, y label, and the title. And if we type figure, it will show us the figure object. So basically, we have two of the same plots because in the for loop, we basically put the same thing. Okay. So, yeah. So commonly, you can also see it here that there is some overlap between y and the y axis of the second plot and the first plot, the end of the first plot, right? So a common issue with Matplotlib is that there is some overlapping of subplots or figures. We can basically use figure.tightLayout or plot.tightLayout method, which automatically adjusts the positions of axis so that there is no overlap. So here again, basically, we are creating a figure and axis object. We are creating two subplots, one row and two columns. Then for each of these axes, we are plotting something. And it should look like this basically, because it's the same code as this. But you notice there is some overlap here. Now what we do is we write plt.tightLayout. Okay. We can also write figure.tightLayout. Doesn't matter. We can use it interchangeably. Now, if we do this, we see that there is a gap here. So basically, it adjusts the placement of the axis such that there is no overlap. Right. Okay. Uh, Matplotlib also allows us to set the aspect ratio, DPI, which is basically the resolution, dots per inch, pixels per inch, or something, and the figure size to be specified when we are creating a figure object. Uh, Figure size basically, fig size, FIGSIZ, is argument that takes a tuple, which is width and height of the figure in inches. DPI is basically pixels per inch. So if we are to create a figure like this, figure is equal to plt dot figure, figure size is 84. It'll basically create a figure. Okay, we need to plot to see it, but basically it will create a figure with size as with a width of 8 inches and a height of 4 inches. Okay, so now we are creating, so yeah, figure size and DPI can also be passed to uh, plt.subplots function. So here we are creating again figure and axis for just one figure, one subplot. We are just having one subplot. We are giving it a figure size of 12.3. Basically, the width should be 12 and the height should be 3 inches. Now we plot X and Y, we set the labels and the title, and we run this code. We see that basically our width has been elongated quite a bit since we changed the figure size here. If we do it 10 comma 3, it will become shorter. If we do it 10 comma 4, the height will also increase. Right. So this way you can change how your plot looks. You can change the aspect ratio. You can change the DPI to change the resolution for managing basically size of images. Or if you have a lot of things to plot, then having a higher resolution might make it better, or it might need slightly more time to plot. Okay. uh, we can save form figures in different formats, including PNG, JPG, and SVG, and PDFs also. So basically, what we do is we call the figure object or the plot object where we have plotted things. So this is the figure object that we have last used and plotted in. So figure dot save fig, and then we give it a name of the file. Okay. Basically, if we run this now, we should have a thing called filename.png, which is basically our plot. We can also set the resolution of the image, and we can set the different output formats by changing the extension here. And we can set the resolution by DPI is equal to 200 or something, 200, 300 or something, and it will basically reflect on the image here. Right. Now that we know about the basics of how we can create a figure, how we can add axis, let us look at how we can decorate a figure with axis label and title we saw before. How can we most importantly add legends to our plot? Okay, so axis.set title is something that I told before. It basically sets the title for a given axis. Okay. Uh, Set X label, set Y label basically sets the X label and the Y label. So the thing that is returning is basically text and where it is placed in the plot. Okay. So this is placed at 0.5 halfway from the left hand side, and 1 basically means on the top of the plot. Here it's halfway on the uh, vertical axis, and then it's placed basically on the left. So it gives you different values. Uh, yeah, yeah. We can use the label argument when we are plotting certain things, so that these things are automatically added to the legend when you call a legend. So first we create a figure object here. We write axis is equal to figure dot add axis. So our axis is at 0, 0, and it has a width of 1 and a height of 1. We are plotting two lines on the axis. We can plot multiple lines on the given axis, on the same axis. So basically axis dot plot x comma x raised to the power 2. So x we had defined somewhere earlier. It's basically 0 to 5 linspace thing. Label here is x raised to the power 2. The second plot we are making is x comma x raised to the power 3. And the label here is x to the power 3. And we write axis dot legend. This method we call. So basically what this does is it shows us a legend. Note that we have not provided different colors here, but still Matplotlib plots them in different colors, so that is easier for us to visualize. Okay. Now if I don't call this legend method, it won't show me a legend. It'll just give me a plot. I have to call the legend method. It will take the label values that you have provided to different plots, and it will correctly assign the label values according to the color of the plot. Okay. So sometimes legend will overlap some of the actual plot that we may have. Okay, in this case, since there's a lot of open space here, Matplotlib has positioned the plot here, the legend here, which does not overlap with our plots here. But in some cases, what it does is it places it here or on the top right corner where it might be overlapping with some of our plots. So what we can do is we can use the location keyword when we are giving a legend, access.legend, location equal to location argument, location equal to 1, 2, 3, 4. 1 is basically to place it in the upper right corner, 2 is for upper left corner, 3 is for lower left corner, and 4 is for lower right corner. So basically counterclockwise, starting from upper right corner. Upper right, upper left, lower right. Okay. So these are the basic options that you have. Uh, if you write location equal to 0, then Matplotlib basically decides what should be the optimal location of your legend. In this case, it's this. If we were to change it, let's say 3, our legend will come here. If we were to change it to 2, our legend will be here. If we were to change it to 1, our legend will be on the upper right corner here. So in most cases, you just need to put 0 or you don't need to put anything because 0 is the default one. So Matplotlib will automatically assign your labels, legends based on your plot so that there is no overlap. But in case there is a overlap or in case you want to set up your legend in one specific particular area, you can use this location argument. Okay. Uh, Matplotlib also gives us a lot of options for customizing. Mm, for example, customizing the color of the plot, the width of lines, the types of lines. Okay, so basically here we are, again, as I talked before, we are creating a figure and an axis using plt.subplots. We are first plotting x and x square, and we are giving it the argument b dot dash. So it basically gives us a blue line with dots. In the second one, we have x cube, and we are giving it g dash dash, which will basically give us a green dashed line. If we were to plot this, we see that this gives us a blue line with dots in between, and the other one gives us a green dashed line. Okay. We can also define colors by using their uh, what are called hex codes. So these are how colors are generally shown in web pages and everything. You can easily get hex codes from websites. So maybe websites like this, HTML color codes or something. If you want this color, it will show you the color. It will give you the hex code for it. It will give you the RGB values and everything. Okay, so you just need to take this, copy it. So if you want this color, you just paste it here, and then that is the color that we'll get for this plot. So we are now plotting three plots in the same, three lines in the same plot. So here basically axis dot plot x comma x plus 1. Okay, on the y-axis we have x plus 1, on the x-axis we have x. It will be a line. So color we are specifically defining, giving it using the argument color is equal to. And here in this first case, we have something called alpha, which basically gives you the transparency. Okay. Now, if you know, if I show you, so it's not quite visible here. If I were to put the alpha at 0.1, you see that the line is less visible now compared to before. Right. If I give it a alpha of 0, the line disappears. It's basically the opacity of the line. If I give it 1 as the maximum value, that is the bluest that we can get. And if I give it a alpha of 0.5, it's basically like half transparent, the line is. Okay. So this also helps you moderate the alpha keyword also helps you moderate your color in some ways. So let's say you want to plot a lot of things that are intersecting, or if you want to plot a circle and a dot in between that, then for the circle, you can make the alpha as zero 0.5 or something so that it's slightly less opaque. It's mostly transparent. And then you basically use that, uh, what do you say, as your circle, as the color for your circle, so that everything else inside the circle is visible. Right. We also have a lot of different line and marker styles that we can use in Matplotlib. Okay. So basically, we can use the line width or LW keyword to set the line width, right? So line width is equal to 0.25, 0.51. 1 is the normal one. 0.25, 0.5 will be half of that. 2 will be twice of that, and so on. Line width. Now, if I were to just run these, you'll see that the first one, x and x plus 1, basically all of them have the color red, but the line width basically increases. So it's 0.25 first, then 0.5, then 1, then 2, and so on. Okay. Now, you also have line style options. Okay. I had to do it separately. So I write here the color for each of these three lines is green. The line width is 3. And the line style here is a dash, the dash and dot. It's a colon. Now, if you plot this, you see that the dash basically gives you a solid line. The dash and dot gives you a dotted solid line. And the colon gives you a dotted line, full dotted line. Okay. So more explicitly, you can use line style and color like this. Otherwise, you can also write G dash dash or G dash or G dash dot, things like that also for short. But it's since like as a beginner, it's more preferable to do this. Right. Uh, you can also customize it so that we set the interval for dashes also. So basically, uh, line is something that we are plotting here. Okay. It basically returns the plot object to us. So we are plotting x and x plus 8. We are giving it the color black and we are saying line width is 1.5. Here, line dot set dashes will basically, so here we are not siding the line in any way in the first line. That we are doing in the second line. So in the second line, what we are doing is we are telling it that the first line should be 5 units long. Then it should have a gap of 10 units. Then it should have a line of 15 units. Then another gap of 10 units. Then 5, 10, 15, 10. So if I were to change this to 10 and run this again, you see that the size here has decreased for the longer segment. So you can customize what kind of dashes you want on a line also using this. Right. Then we have marker symbols. So we'll do that. Basically, here again, we are creating a figure and an axis. We are plotting the lines x and x plus 9, x plus 10, 11, 12, 4 of these. Okay. We are writing that the color, all of them should be blue. The line width for all of them should be 3. The line style for the first one is a dash, which is a solid line. For the second one, it's a dash line. For the third one, it's a solid. For the fourth one, it's a dash line. Then we are giving it additional argument called marker. Marker basically tells you what marks to put in between the line. So if you were to run this, we see in the first case, we have x plus 9, x and x plus 9 wala case. We have line style as dash, so it's a solid line. And we have marker as plus. So basically, each of these is a plus here, right? Then in the second case, we have line style dash dash. So it's a dotted line, dash line, sorry. And then we have the marker O, which gives us a zero or a circle or a point. For the third one, we have a solid line, and the marker here is S, which is basically a square, right? In the fourth one, we have marker is equal to 1, which is basically this thing. So you can see all these values of markers uh, and line width and everything. All of these things you can figure out online. So if you put a dot as a marker, it will be a point. If you put a comma, it will be a pixel. Uh, O is a circle as we saw before. Then 1 is basically this symbol, triangle down a bit. Now hopefully you can see. So 1 is basically this symbol, triangle down. 0 is another one we use, which is a circle, right? Then we also use S, which is a square, and we use plus, which is basically a plus. You have cross, you have filled cross, you have a diamond, and all sorts of things. Okay, so that's how you style the lines in Matplotlib. And finally, we can also change the size and uh, colors of the markers. So basically here in the first plot, we have all of the plots have purple lines, purple color of the line. Line width for all of them is 1. The line style for all of them is solid. 3 of them have O markers, so basically circles. And here we are saying first one has marker size 2, so this is small. Second one has 4, so this is relatively larger, twice as much. Then we have marker size 8, which is 4 times as much. And we also have another argument here, marker face color, which is red. So basically the face color of the marker here is red. The filling inside the marker is red. Okay. In the fourth line, what we have is we have purple line with one solid line. Then we have marker which is square. We have marker size which is 8. So these two are of the same size. We have face color which is yellow. So basically the fill inside the marker is yellow. And we have marker edge width. So basically the width of the edge that each marker has, the outline, which is 3, and marker edge color, which is green. So the basically our squares now look like green boxes filled with yellow. Okay, that is all about markers and line styling and all. Now we'll just run it all together so we can see all of them in a single figure. What all we learned. We can change the size of the line. We can change the type of the line. We can use custom dashes in the line. We can set markers, different markers on the line. We can even change the features and size and color and shape of the markers. Right? Yeah. So here we'll look at how our we Matplotlib also allows us to have full control over the axis, how our axis appears, to like how it is visible and all. So in this section, we will look at controlling axis sizing properties in a figure. So 1 second. Yeah. Yeah. We can configure the range of different axes using the set ylim and set xlim methods. Okay. Uh, we can also use axis tight to get like automatically fitted images. So plt.tight layout and things like that. We can do the same for axis. So here what we are doing is we are creating a figure and axis object using this subplot method. So basically we have three subplots here, one row and three columns, one row and three columns. And the figure size we are providing here is 12, 4. So the width of the figure is 12 and the height of the figure is 4. So now we have an axis object, which is basically a list. If we take axis and index it 0, we'll get the first object. So the first subplot here is what we'll get. Axis 0 dot plot x, comma x raised to the power 2, comma x raised to the power 3. And axis 0 dot set title default axis ranges. So what happens if we run this? We basically run it and figure out. If we run this, we basically have both the plots. So plot, we can just plot two separate plots like this also. We plotted both of them. And we have the default ranges for the axis, which is the y-axis goes till 120, the x-axis goes till 5. Okay. Now what we are doing in the middle plot, the second plot here. So axis index is 1. So this is index 0, this is index 1, this is index 2. Here we are again plotting x raised to the power 2 and x raised to the power 3. And we are saying axis tight. Basically, this will give us a tight axis automatically determined by Matplotlib. So this is basically how it looks like. It's basically the same thing in this case, but it might differ in each cases. Okay. Then in the third case, what we are doing here is we are basically setting custom limits on our axis. So set y lim 0 to 60. Okay. Set x lim 2 to 5. Now if we run this in the third axis, we see it the x-axis starts from 2 to 5. The y-axis starts from 0 to 60, unlike all these. Right. We can use set underscore y lim. Then the argument, we have to give it a list of two values, start and stop. For xlim also, we give it a list of two values, 2 and 5, start and stop, set xlim. So basically, that's how we set the limits of the axis. Then there are a lot of special types of plots, such as bar plots, histograms, scatter plots, and uh, yeah. So I'll show you a few examples here. But mostly for data science, we'll be using another library called Seaborn, which is basically built on top of Matplotlib. And it helps us do all these things, like plot all these complex figures in a much more easier way with less amount of code, basically. So let's see again what we have as our x and our y. So we have x is this list from 0 to 5 and y is the square of it. So we are doing plt.scatter. Instead of plt.plot, we do plt.scatter x and y. So what this gives us is a scatter plot where the x values are here, the y values are here. Okay. We can again, like before, plt.xlabel, plt.ylabel, plt.title. We can put this, so we get the title, we get the X label, and we get the Y label. Okay. Then we can also plot a histogram. Okay. So basically what we are doing here is we are generating a data. So we are importing sample function from random library. We are basically sampling 1,000 variables. Okay, it's a list of 1,000 variables that we have sampled. Just a second. List of 100 variables in the range of 1 to 1,000. Okay, so if I were to do length of data, I should get 100. Yeah. And if I just write data, I'll get all the values. It's basically 100 data points in the range from 1 to 1,000. Okay. Uh, then what we want a histogram of the data set. So we do plt.hist and we give it the data, this thing. So in case of histogram, you don't need X and Y because it will automatically calculate the frequency and plot the frequency of all the variables in X. So this is how a histogram looks like. Right. We can again use the y-axis here will be frequency of a number and the x label will be x values and title will be this right histogram. If we run this, we write x frequency and histogram. We can also use the function bins, which will basically tell Matplotlib how many bins to make. Okay, so basically this is making 100 bins in the whole data. If I give it 50, it will make 50 bins in the whole data. Okay, of equal length. If I give it 5, it will make 5 bins of the whole data. And if I give it 10, it will give 10 bins of the whole data. Right. So depending on how many bins you want, you can use uh, the bins function here to get the uh, number of bins. Sometimes you don't know how many uh, bins you want, okay, for your data set. So in that case, maybe you want to so the default value here is 10. So, but in some cases, you might not want 10 bins. You might want different number of bins or different sizes of bin width so that you can easily visualize your data. So in that case, what you can do here is basically use auto, which will give you automatic number of bins. You can also use predefined functions such as cot or Sturgis or other values, which will basically change the binning of the data depending on some mathematical function that has been defined to find optimal number of bins. So there are a lot of algorithms that are present, which basically help us determine the number of bins that you should plot. So the values that this argument can take are auto, FD, Doan, Scott, and so on. Okay. So yeah, that about histograms. Uh, then we can also plot box plot. Basically, I'll just create the data separately. Yeah. So basically here I have a data which is basically drawn from the normal distribution. Okay. So from 4 normal distributions, we are drawing data. So we have 4 arrays inside the list. The length of the data variable that we have here should be 4, 3. Okay. 1 to 4. So 1, 2, 3. Basically, yeah. 3. We have 3 arrays inside this list. In one array, we have 100 values drawn from a normal distribution with mean 0 and standard deviation as 1, 2, 3. Okay, so this is basically list comprehension. I think we talked about this. So what if I write, what this part basically does is it creates a list. Standard first, standard in range 1 to 4. So this will take the values 1, 2, 3. So we are just putting standard here. So we'll just get 1, 2, 3. If we do this, we get a list 1, 2, 3. Now if I write here standard square, then we'll get 149. Okay. So this standard value is basically values from the range 1 to 4. And this is basically what the value we want in the list for the corresponding value of this STD variable, standard or whatever, standard deviation in this case. So here we are using this function basically, which gives us the, so we are using this as standard deviation as the value of standard deviation in our normal distribution to pick out 100 values. So this will again give us the same array, right? So here we have the data. We have basically 3 arrays. Changes from 1 to 3. Okay. So now to plot a box plot, basically you write plt.boxplot. You give it the data. What? 1 second. Yeah, sorry. I thought I got disconnected. Yeah. So yeah, you basically we are giving these arguments. I'll tell you more about it. So this basically we see the distribution. All of them have the mean 0. So all of them, the median is almost close to 0 because we are drawing from normal distribution. The median should be close to 0. Ideally, it should be 0, but close to 0. Then we have the first quartile, the third quartile, the median here. Then we have the whiskers, and we have outliers. Right. This is basically the box plot. So for all 3 cases, since the means are same, the means are basically the plots are centered along 0. But since the standard deviation is different in all 3 cases, it increases from one case to the other. We increase the standard deviation. So the uh, box length and the whiskers and all also increases. Okay, so now we'll look at these options that we provided. So the first thing is vert is equal to true. Now, if I were to write vert is equal to false, what it'll do is it'll plot it horizontally. So by default, I think Matplotlib plots it. By default, Matplotlib plots it vertically. So you don't need to give it vert equal to true. It'll anyways plot it as vertical. But in case you want to plot it horizontally, you give it vert equal to false and it will plot it as horizontally. I'll just change it back to true. Okay, now we have a vertical plot. Then this patch artist basically uh, it's a method of plotting. So basically it uses a different component of Matplotlib to plot and it fills in the boxes. If you give it patch artist equal to false, it basically produces just the boxes with lines. And if you give it patch artist equal to true, it basically also fills up the patches of the boxes. So depending on what you prefer or what you want, you can basically uh, change your plot accordingly. Okay. Uh, that is mostly it for Matplotlib. In the next class, uh, sorry, yeah, we have exercises for module 5. Okay. I'll be sharing it. So basically, these are simple questions in Matplotlib. You have to import Matplotlib, pandas, and NumPy, all three of them. Then the first question is to create a histogram, add legends and all, make multiple plots, uh, plot a bar graph, scatter plot, pie chart, and stacked bar chart and everything. So these all are very simple kinds of graphs that you can plot using uh, Matplotlib. So I'll also give you a data, uh, company sales data. So actually, this is a question that we can basically try out. So since we have not tried out tried it out exactly, I have not told you how to do a pie chart. Figuring out that and doing all this might be a bit too much. So this question will solve it now. So first we'll import Matplotlib, will import NumPy, will import pandas. Okay. Then what we are asked is using the file provided. So this is the file that we are given here, company sales data. Calculate the total sale data for last year for each product and show it using a pie chart. So we write df is equal to pd dot read csv, and yeah, we give it the name of the file, company sales data dot csv. We just want to check the data frame. So this is how it looks like. Calculate the total sale data for the last year. So we have data for all the months, 1 to 12. Okay. We want the total sale data for each product. So each product is different row. Right. We just need to add it by row. Okay. We basically use the sum function to get, basically we can disregard, you don't need to actually regard all of them. We can basically, oh, we don't need to use a lock here. Uh, okay. So for face cream and everything, we can mm, basically get our values using the sum function. Right. Df dot sum. We get all the values, and we don't want all of them. We don't want the month number and all. Okay. We'll just write whatever we want. And just print the data frame. I know what all is there. Face cream, but I think so. There's no space here. That's right. Okay. We also have face wash, and we have toothpaste. I forgot to put inverted commas here. Right. Then we have shampoo and moisturizer. Shampoo, moisturizer. We can basically select all of them first and then get the sum. Just a second. To select multiple rows, we need to put a moisturizer, not an index. RIZDR. Of course. Okay, so now we have the values for all these things. What is the total sale? Okay, then what we do is plt.py. Just give it this. Okay, we basically got a pie chart, but we didn't get the labels. Okay, so for labels, we need to put here labels equal to, let's just create another series object instead of typing this too many times. Sorry. Total sales is what we'll call this, is this. It's basically total sales, and the labels is total sales dot index. Right. So now we got a plot. We got all the sales for it. We got a basically a plot pie chart for the whole thing, and it's color coded according to the object. Object as in like whatever product that we have here. Right. That's it. So I don't expect you to like do a lot of optimized or like very beautiful pie charts and everything. Matplotlib basically for this uh, course, the charts that we are drawing here is basically for your practice only. So you don't need to exactly do a make a professional publication grade picture or whatever. So I just want you to learn about all these functions that are there for Matplotlib. Scatterplot we talked about, pie chart we just looked at. You should take a look at stacked bar chart, how it looks like, and like what are the other kinds of plots that you can make. Okay, subplots and all things like that. I just want you to be slightly comfortable comfortable with using Matplotlib because this is the main plotting library that is there for Python. The other one we'll talk about next week basically is uh, Seaborn. So Seaborn is basically built on top of Matplotlib, and it was well known. It's a well-known Python library for data visualization. It offers a very user-friendly interface, and it can help us create a lot of uh, not a lot of basically it can help us create plots uh, be, without like worrying much about the aesthetics of the plots or each individual element of the plot. Okay, so basically there's a great statement that someone has made on the internet, which basically encapsulates the difference between Matplotlib and Seaborn. So if Matplotlib tried to make easy things easy and hard things possible, Seaborn tried to make a well-defined set of hard things easy to do. Okay. Still, people will like we'll all be using Matplotlib for a lot of our plotting analysis. But Seaborn basically helps us easily explore our data by making the most common and slightly harder plots to make in Matplotlib. Most common as in the plots that we'll be needing the most in data science. Making those is much easier in Seaborn. So basically, we use Seaborn in cases like that. So we'll take a look at that in next class. Uh, So we'll not be having a class tomorrow since there's a lot of things coming up, uh, uh, meetings and like some open day things here at IIC. So we'll have our class next week on Thursday, and then next week Friday also. I don't think we'll have a class. We'll have a class next week Thursday where we'll talk about C1 and we'll discuss Matplotlib exercises. Uh, we'll also mostly discuss the exercises on C1 in the same class. Depends on how much time we have. Then I'll not give it to you as homework because it's much more better if it's illustrated, right? How to think about problems and all. Then the next week we'll uh, probably have a session on exploratory data analysis, where next week, where we'll basically take a few data sets and try to look at and identify patterns. That's something I have been thinking of doing, but uh, yeah, it's been kind of difficult to put it together. But yeah, I hope by next week it's all done, and so we'll have the next class next week Thursday, and then we'll meet again next Thursday. So I'll just provide you with this exercises and the files required and the Jupyter notebooks for Matplotlib. And we'll meet next class on Thursday. Thank you for attending.